So can a computer actually have emotions? I know, it sounds like something straight out of science fiction, right? But this is a question scientists are taking very, very seriously. And the answer? Well, it might just change everything we think we know about intelligence itself.
Okay, let's start with something I'm pretty sure we've all done. Be honest. You're working on something important, the deadline is looming, and your machine just freezes. And you find yourself shouting at it, right? Come on, you stupid thing. We get so frustrated with a machine that just doesn't seem to get it.
You know that frustration? It actually says a lot about how we usually think about our tech. We tend to see emotions as this messy, irrational bug. We want our computers to be clean, logical, and purely rational.
But here's a thought. What if we've got it completely backward? According to Rosalind Picard, who's a real pioneer in this field, emotion isn't a bug at all, it's a feature. Now, this idea reframes everything. It suggests that emotion isn't the enemy of intelligence. It's a critical part of what makes intelligence actually work.
All right, so let's dive into that. Why would we even want our technology to be emotional in the first place? I mean, really, what's the point?
Well, think about a baby. A baby can't talk, right? But they are masters of communication. They use emotional expressions, crying, laughing, you name it, to signal vital needs. Now think about a computer. It has vital needs too. It might be running low on memory or starting to overheat. What if it could express those internal states to us? It could make them much more intelligent and effective partners.
Okay, so the road to building an emotional machine, it doesn't actually start with the machine feeling anything. Nope, it starts with something a lot simpler but incredibly powerful, and that's recognition. A computer, you see, could learn to read our feelings by basically becoming this super detective. It could look at the obvious clues, sure, like your facial expression or the tone of your voice, but it could also analyze all these hidden signals, things like tiny changes in your sweat, your heart rate, your body temp, stuff that even we don't consciously notice.
But here's the thing. Just grabbing all that raw data, it's not enough, not for real understanding. Because an emotional signal without context, well, it's pretty much meaningless. Just take a smile, for instance. A smile when you get good news, that's pure happiness. But a smile at a funeral, that could be masking some really deep sadness. So a truly intelligent system has to be able to reason about the entire situation to get what the emotion really is. It can't just take that smile at face value. Okay, so let's say we've got a machine that can recognize how we're feeling. What's the next logical step in this whole journey? Well, it needs to be able to express emotions back to us.
And to get our heads around that, we need to talk about this really cool concept called affective bandwidth. Basically, it's a measure of how much emotional information a message can carry.
Think about it like this. A real face-to-face chat? That has super high bandwidth. You've got tone, facial expressions, body language, the whole shebang. A text message, though, that's got really low effective bandwidth. So a big goal of this field of affective computing is to boost the emotional richness of how we interact with our devices. You know, we've seen computers try to express emotions for decades, even in these really simple ways. Like, remember the iconic Happy Mac startup screen? It looks happy, right? But it's just a drawing. It's a programmed behavior with zero feeling behind it. And that gap, that huge gap between showing an emotion and having an emotion, that leads us to the biggest question of all. And this is where we get to the heart of it all. The most profound, the most complex, the most, well, mind-bending part of this whole idea. We're moving beyond just recognizing or expressing emotion to the idea of a machine actually having it. I mean, it's one thing to program a computer to look sad when you're sad, but what would it take for that machine to actually genuinely feel sadness? What does that even mean? To even begin to answer that, the field has come up with a kind of blueprint. The argument is that for any system, any computer, to truly have emotions, it needs to have a system with 5 key parts, all working together. Let's walk through them. Okay, number 1, emotional behavior. The system has to act in a way that looks emotional to us on the outside. It could be super simple, like a little robot that seems aggressive because its only rule is to move towards a bright light. There's nothing going on inside, but from our perspective, the behavior is there. Number 2, fast primary emotions. Now this is about those super quick gut reactions. You know, like when you jump out of the way of a car before you even consciously realize what's happening. That's a hardwired survival instinct. A machine would need its own version of that kind of fast, reflexive response. All right, component 3, cognitively generated emotions. So these are the total opposite of the last ones. These are the slow emotions, the ones that come from thinking and reasoning about things. It's that feeling of pride you get after you finally finish a huge project, or maybe disappointment when a vacation you planned gets canceled. It's emotion that's born from thought.
Okay, number 4, and honestly, this is the really tricky one. It's the emotional experience. This isn't just one simple thing. It's about being aware that you're in an emotional state. It's about sensing those physical changes like your heart racing. And it's about that subjective, internal, what it's likeness of an emotion that's so personal and so hard to put into words.
And last but not least, number 5, body-mind interactions. The point here is that these emotions can't just be sitting off in a corner by themselves. They have to connect to everything else. They have to influence the system's other processes, like how it makes decisions, what it remembers, and how it learns.
So, after laying out that whole 5-part blueprint, where does that leave us? What does this all mean for the future of intelligence, both for us and for our machines?
So here's the crucial takeaway. Having an emotion isn't some single switch you can just flip on in a program. No, it's something that emerges from a really complex system where all 5 of those pieces, the behavior, the quick reactions, the slow reasoning, the internal experience, and the way it all connects, are all firing at once.
And that brings us to one last really provocative thought to leave you with. Let's say someday a machine could perfectly replicate all 5 parts of that system. If it acts sad and it tells you it feels sad because it has reasoned about its situation, at what point does a perfect simulation just become the real thing? Is there even a difference?